Well, that stinks. This is the handle off of the tool post for the Bardons and Oliver turret lathe. Not sure exactly what happened. It just kind of broke. So now I need to make another one. So anyway, this is the tool turret. It's got a bearing on top there, and this screws down over top of that bearing. Anyway, let's make some parts. So here I start off with a piece of 3/4 inch thick steel plate. This is cold rolled 1018. I'm pre-drilling some holes. And now we're using a pre-drill so that it can be tapped, and then I instantly over-drilled it. So I had to make a decision whether to scrap the part and start over, or to let it keep running and see what else I screwed up. I decided to let it keep running. Experience has taught me that in more cases than not, I've screwed something else up. Now we're doing some perimeter passes. This is a Lakeshore Carbide 4-flute roughing end mill that I'm running at 1166 RPMs, 9 inches a minute, at a 0.15 depth of cut. I really like the way these cut, and presumably you can plunge with them, but I've never had any luck with that, which is why I have the extra holes. You can see that the tool plunges into the empty space of the drilled hole and then ramps in from the side. So I've had to make this handle in 3 pieces: the handle itself, the nut, and then the washer. I made the washer thick on purpose because when the handle screws on, there's no telling where the handle's going to point once it's tightened down. It would not be good to have it pointing towards the middle of the machine, so I made this washer thick so that I could take some of that extra material off should it be facing the wrong direction. And here's our finished pass. This is a standard 4-flute steel end mill, 1400 on the RPMs, 9 inches a minute, and full depth of cut, leaving a couple tabs to hold the pieces in. And this is the original handle, the one I screwed up, and I'm glad I let it run because I found out it was too short. So I made this one longer, and I also get rid of that detail line. Turns out I didn't like that. So now we're going to chuck it up in the mill so that I can tap that hole. Now we're going to use an edge finder. Mark our 0 on one side, go to the other side, and in Mach 3, if you put divided by 2, that gives you half the length. Then go down to the command line, G0, X0, enter. That goes right to the center. We'll do the same thing for the Y. So now I'm centered up on that hole. I'm going to use this guide to help me tap that hole. 1/2 by 13 threads, so this was not something that was accomplished without much effort. So here are the parts bolted to the, or threaded onto the tool post, and you can see that when you turn the handle, it turns this cam on the bottom, and that bottom plunger comes out, releasing a plunger underneath of the tool turret so that it can spin. Took a little fussing about to get it to the right tension, but it ended up working out. So here it is. Got myself a new handle. Hopefully it lasts as long as the original did, which is about 60 years. It sure is nice to be able to crank out a part when you break something, and you don't have to track it down. Well, that's it. Thanks for watching.